What's up guys, welcome back to Tank Control Games. This is episode 3 of my surface detection series in Unreal Engine 5, and today we're going to be adding Footstep VFX based on surface type. So you can see as I'm walking across these different surfaces, there's a different effect playing based on the material. Another thing you'll note is if we walk or run, we also are going to be scaling our VFX particles based on the player's speed. So if that sounds cool to you, stick around, and if you haven't caught the first episode, it's linked in the description of this video. So make sure you like and subscribe, and let's get started. There's a link in the video description to this Niagara Footstep VFX pack by Sidearm Studios, and this is a free pack on the Fab Marketplace, and this is going to have all of the particle systems that we need for this tutorial. And the nice thing about this is we won't have to create these from scratch, but we are going to be modifying these a little later on. So download this pack and add it to your project before we get started. Okay, so when your project loads, make sure you have the VFX pack downloaded, and then just check under the Niagara FX folder and particle systems, and you'll see, if you scroll down, all of the systems that we need. One other thing that we're going to do just to make debugging some of this a little easier, if we go under the third person character, let's just add a input, and we'll use like our E key for now. And when we press E, let's get a flip-flop node, which will just alternate between A and B every time you press this. And we want to do set global time dilation. And when we press that, we'll set it to something slower, so maybe like 0.4, and then when we press it again, it'll go back to 1. And if you do compile and save, all this is going to do is going to do slow-mo when you press E. And this will just be really helpful for debugging so we can actually see what's going on with our VFX as we're walking across these surfaces. Okay, so back in our character graph, what we're going to do is we're going to highlight all of the logic for footsteps, and let's just right click and collapse that to a function. And we can just rename that set footstep sound, and then double click that function open. And one last thing we're going to do is we'll drag off of our location under spawn sound at location, and we'll hook that up to our entry node. And this is just because we're going to want to feed in that location once we do our line trace. So this will just keep things a little cleaner. And then the next thing that we're going to do is actually set up a function to perform the line trace whenever there's a footstep. So what we can do is create a new function and just call that foot trace. Okay, so we can drag our function in the graph, hook it up, and we'll hook it up before footstep sound. And then we want this function to take in an input, and it's going to take in current step type, which is E step type. So if we click on our entry node and click the input plus, let's just say step type, and then do E step type. Okay, so drag off of step type and search for select. And then this will give us our left and right, and then just right click on one of those and do change pin type. And then it's wildcard right now, which means it has no variable type, and it's just kind of waiting for an input. So what we actually want to set it to is name. So foot L and foot R. Now drag off the return node, and let's do get socket location. And then it's going to use our mesh, so just choose the bottom one. And then we're going to do line trace by channel, so search that. And then this is just going to be a single line trace, so just make sure you don't do multi. And then hook that up just like that. And then our starting location is just going to be the foot location, so just plug directly off of socket location into the start. And then our end location is just going to be that location plus -50. And then just hook that up to end. Okay, and then just to visualize this, let's set draw debug type just temporarily to for duration. And if we click play now, it's just going to play the left foot because we actually haven't hooked up our step type to our function. So let's drag out current step type and just hook that up there like that. Do compile, and then let's click play. And there you go. So now those little red squares are just indicating the line trace, indicating a hit. So we can see that's working. And then what we can do with that is, so let's just undo our draw debug type, and then we can drag off of out hit and do break hit result. And then if you click this little drop down, you'll see all of the things that we can get off of the hit result. And there's a few things we're concerned with here. We want location and the normal. And we're going to use both of those to set both our footstep sound location and our VFX. So let's add a return node. And then let's hook up location to the return node, normal to the return node. And then one other thing we'll just do in this function too, we do also want our line trace to set our current surface, even though we're doing it off the capsule, and that's kind of, on tick currently. You still might get a scenario where that's detecting based on the capsule, but your foot is a little bit ahead, and that could cause a problem where you're not getting the right VFX. So what we actually want to do here too is drag off of physical material, and then look for surface type. So get surface type, and then we're just gonna set our surface type, our current surface variable based on that surface type. So that'll just prevent a bug later on. So just hook that up like that. And then now we're getting our location normal and setting the surface all in this foot trace function. So outside of the function, what we can do is hook up location just directly into footstep sound, and then that's done for now. We'll probably mess with some attenuation radius stuff later on, but for now, this will do it for our footstep sounds. And then now we can start our function for VFX. So let's create another function, spawn footstep effect. And this function is going to take in 2 inputs, and it's going to take in our location and our normal. So we'll just do 2 vectors. So 1 for location and 1 for normal. So then what we're going to do in this function is similar to what we're doing for audio. We're going to right click and we're going to do spawn system at location. And like we've been doing for this whole tutorial, we want this to be expandable, so we're going to use a select node again. So drag off of system template and then choose select. And then instead of wildcard for our index, we're going to use current surface. So now again, we got all of our different surface types. So just like we were doing before with our MetaSounds, we're going to create variables for each of these, and these are Niagara particle systems. So what we can do is just create a new variable, name it NS for Niagara system underscore footsteps, and maybe we'll just say footsteps VFX and call this one default. And instead of Boolean, this is going to be Niagara system and object reference. So we have our default one, let's just hook that up there. And then what default will actually mean for us, let's set this to be just kind of like a generic dust. So if we go back to our surface footstep pack and go in Niagara VFX and particle systems, we could make this either general or dirt. Let's see what general looks like. So yeah, it's just a generic kind of dust effect, and I think that'll be fine for stepping on most surfaces. So we'll just take our variable here and we'll just make that the general surface 1. And then for ice, snow, grass, you can pick whatever ones you want. I'm going to go through and set them to be kind of their corresponding particle system based on this pack. So there's one for water and some other ones. But again, you can choose whatever you want for these materials. So I'm going to go do that and then we'll continue. Okay, so I have all of my different particle systems added. And then what we can do is we can just hook up our location to location, and then we can drag off of normal. And then what we want to do for normal is make rot from Z, and then plug that into rotation. And that's just going to make sure that our particles are rotated the correct way. So you probably noticed these settings under our spawn system at location node, and we're going to keep all of these the same except for pooling method, which will change to manual release. So if you don't know what pooling is, pooling basically lets Unreal reuse Niagara components instead of constantly creating and destroying them, which is really inefficient. So we can hook up our spawn footstep effect to our node, and then now this is everything we need to have this functioning. So what we can do is go back 1 level, and then we don't have our function hooked up, so let's just drag out spawn footstep effect, and we can just do it after we spawn the sound. And then let's drag our location also into this node and our normal into this node as well. And then you can just add some reroutes to clean that up slightly. So now if we click compile and click play, There you go. Now you see our footsteps are playing based on each surface type. It's a little hard to see on the normal one, but there's like a little poof of dust. Probably overkill for a surface that doesn't really need it, so feel free to like change that and just remove it. But yeah, this is working for now, so all of our steps are working. But you'll notice like the effect, if you're walking or running, is always the same size, which doesn't look great. Like if you're walking on mud, you know, maybe you don't want this drastic of a mud splash, and maybe you only want that when you're running. So that's something we can change now. To actually test this, since mud currently you can only walk on it, let's just change our default value under mud, and let's just allow running on mud. So we'll say max run speed and just set that to 600. And then let's duplicate our mud and let's just make this like a longer stretch of mud so we can actually test running. So what we can actually do on each Niagara system, if we go back into our spawn footstep effect, since we do get a return value here, we can actually change our Niagara system at runtime, basically by just setting variables on the system itself. So what we're going to do is probably open up mud and water. I think those would be the clearest examples of kind of doing this speed change and seeing it adjust in real time. So let's open up mud first. And this is Niagara's graph. So if you've never messed around with Niagara particle systems, just like we were doing like MetaSounds and you know, the material graph or the animation graph, everything in Unreal kind of has a graph-based system, and just like all the other graphs, you can add attributes and variables. So in our Niagara system, you'll see these orange nodes, and these are emitters, and these control things like the particle spawn rate, the velocity, and the color. And for this tutorial, we're just going to be modifying spawn burst instantaneous, which is where you'll see your spawn count get set. So to actually modify that at runtime, what we're going to do is add a user parameter. So if we click this little plus, we can do make new, and then go under common and float, and let's just name that intensity. And you can just leave that at 0 for now. So what we can do is click on our spawn burst instantaneous, and we're going to do this for each of these emitters. And then under spawn count, instead of hard coding that value, we're going to copy that value. So we still want it to default at 50 for just like whatever your max speed is maybe. And then what we can do is we can create a new expression. So click this drop down and then do new expression. And then you'll see that it now changed. Now it says custom HLSL. And that stands for high level shading language. So this is a scripting language that's kind of based off of C. And we're not going to get too deep into this. There are tutorials for this on YouTube, but we are going to create a custom script here that lets us scale our previous default value by our intensity float. And we're going to drive that intensity based on player speed. So for this expression, it's written out in the description of this video, so you can just copy and paste it from there. And I'm actually going to do the same. Okay, so I can explain what this is doing really quick. So this expression is just taking our fixed spawn count and turning it into something that reacts to speed. So we start by converting everything to an integer, since Niagara spawn counts have to be whole numbers. Inside that, we round the value to keep it stable. Then we take the original spawn count and multiply it by the intensity parameter that we created, which will come from our character's movement speed. The intensity is then clamped between 0 and 2, and that just keeps it in a safe range so we don't explode our particle counts. Then the end count is a spawn result where 0 means no particles and 1 is the default behavior that we had before. And higher values would just give you heavier splashes, which is why we're kind of capping it at 2. So the last thing that we need to do is replace our base spawn count with what this default was originally, so it was just 50 here. And then once you do that, your system should compile. So you're going to want to do that for each of these nodes, and just go through and add the expression and make sure you're inputting the default value. And then once you do that, click compile, and then we'll jump to the next section. Okay, so I added that expression to each of these nodes, and then made sure that my default value is added back into them. So now you'll see, once you do that, you'll see no effect. And that's because our intensity is defaulting to 0, but if you just set it to 1, then you'll see the full effect that you were seeing before. So we are going to drive that parameter in our character blueprint, so let's jump back there. And what we want to do is drag off of our system that gets spawned, and then we're going to do set Niagara variable float. And then in float name, it's just going to be intensity. And then for the value, we're going to use our player speed to generate that. So what we can do is get our character movement, and then get velocity, and then do vector length. And then we're going to clamp this, and we'll do map range clamped. And then for that range, we want the max speed that the player could ever really move. So I think in almost all of our movement settings, we did like 600. And then we just want to change that to be 0 to 1. And then we can add a power node if we want to do a little bit of a bigger range when you're walking versus running, and that kind of scale difference between the effects. And I'm probably going to do that. It might just look a little better. So I'm going to do power, the power of 2. And then you can just hook that to the in value. And then do compile. And then we'll go test this on the mud. Okay, so back in our level, I added a big thing of water for us to test and a big thing of mud. And I did go through the water effect as well and just made sure that we have our expression there. So now we should be able to test this out. So if we click play and we walk through the water, you know what, let's do it in our slow-mo so we can see it better. You'll see that kind of smaller size water effect. But as soon as we start to run, the splash gets bigger. And that's exactly what we want. We're basically scaling the number of particles based on how fast or slow the player's moving. And that feels really dynamic and more realistic than if every single splash was just the same size. And then we can test this on the mud as well. So mud, we have little splashes when you're walking, and then big splashes when you're running. So that's all working. And then if we go back to grass, we can just see grass effect changing, snow effect changing. And I didn't add our expressions to those, but feel free to add it to any of these VFX that you want, where you basically want that kind of scaling effect versus walking and running. But I think that's going to wrap it up for this video. So in the next one, I think we will finally tackle adding actual footprints when you cross over certain materials like mud or snow. And they'll kind of last for a period of time and then fade away. But did you enjoy this video? If you did, please leave a like and subscribe. It helps my channel grow. If you have any suggestions for future tutorials, drop them in the comments down below. And if you have any troubles with this setup, just message me on Discord. It's a good place to get some debugging answers or to just show off your work. I'd love to see it. So thank you all for watching, and I'll see you in the next one.